Hello everybody, today we're going to talk about the quadratic formula. Excuse me. So formulas are something that are really daunting. There's something in my throat. So whenever you hear the word formula, you kind of think of to be very daunting and big and impossible to memorize. But formulas are actually gotten from very basic things. And basically we're going to be deriving the quadratic formula, which is used to solve quadratic equations. So firstly, what is a quadratic equation? Well, we know it. It's just in the form of ax squared plus bx plus c is equal to 0, where, let me actually write this to the side, where, right, a comma b comma c are any number, 2.1, 2.2, 5, 6, negatives, any number they can think of, right? They can be anything. So let's even actually solve the quadratic formula. So let's even actually solve this equation using, like with these variables itself. How would you do that? Well, maybe I can get rid of the a first, because that seems like a very weird term. So I'll divide all sides by a. So what you get is x squared plus b over a, x plus c over a is equal to 0. So basically 0 over a is 0, so we know that. Now, maybe I can subtract c over a from both sides. Okay, this seems nice. Now what do? If I were to multiply by a over b, a over b would be added to that. Basically, actually, if I were to multiply by a over b, it will cancel out this term, but then a over b would also be added to the x squared term. So that doesn't work. But then maybe we could turn this guy into, maybe we could turn the left-hand side into a form of a plus b whole squared. And basically we know the expansion. It is actually a squared plus 2ab plus b squared. So now what do? But then you'll be like, okay, I don't see 3 terms on the right hand side. How do I do it now? Well, maybe one term is just not there. Maybe you can just add that term and it'll work. But the first thing we need to know some of the terms. So we do know what x is. It's just, well, I'm sorry. We do know what a is. It's just x. But then we don't know b. So let me just write that down. So we don't know b. So we already have the part of x squared plus 2x followed by b. Actually, rather, I don't like it that way. 2b followed by an x. And this is also supposed to be orange. Color coding takes a lot of time. Plus b squared. Right? And then we see our x squared term, these two x squareds. But I don't see a b squared term. Where's my b squared term anywhere? Right? I don't see another term squared. But then I do see some constant or some value followed by x, right? And that is this guy over here. It's 2bx. But then where did the 2 go? I don't see a 2 in front of that. Well, maybe the 2 was canceled out. So maybe this was something like this. 2 multiplied by something. So basically just 2 multiplied by x. So if let's see if we can actually just solve it. 2 multiplied by some value, let's call it z, is equal to b over a. So let's solve for z. Well, we can just divide both sides of this. We can basically, we can multiply by 1 over 2. So the 2 cancels out over here. And what we get is z is equal to b over 2a. So now we know that our b term is, or basically or basically how do we get this guy? So then if it canceled out and then the x is already there, then b should be b over 2a, right? Because then the form would actually work out perfectly. Let me write it down. It would be x squared plus 2, and then it would be b over 2a, and then the x. So everything works out. It is 2ab, 2a and b, or basically 2bx, right? So 2bx. So then what happened was just the 2's canceled out, and what we got was x squared plus b over a x. So it's really simple. So we actually solved for a and b. Let me just get rid of that. Irritating. So we actually solved for a and b. So now we know b is actually b over 2a. So let's actually put that in. Let me put that in. X squared plus b over 2a. Or sorry, b over a, just b over a, x. So whatever you had before, nothing else. But then if I actually wanted to complete the square, then I just need this b over 2a term added, b over 2a squared, because it's b squared at the end. So we can just add that. It's simple. Just add my b over 2a. Excuse me, that's a mess. Just b over 2a whole squared. Now, since I did it to one side of the equation, I need to do the other side, which is negative c over a. So it's equal to negative c over a plus b over 2a whole squared. So now this whole term, what does it become? Well, it just becomes in the form of x plus b over 2a. So it just becomes x plus b over 2a. And we're done. And this thing will square, right? Because of whatever's written over here. So that is equal to, how do I simplify this expression? Well, maybe you can expand b over 2a. If I were to expand b over 2a, that would be b squared over 4a squared. So that's just got simplified. Now we need to somehow add it to this guy. How do I do that? Well, we know to add fractions, we need to have the same denominator. So if I multiply a with 4a, it does become a 4a squared. So then what I do is if we're to multiplying it, I get minus 4a. So basically multiplying by 4a over here, multiplying by 4a and then c, because the c is already there, right? Then I have my plus b squared over 4a squared. Happy with it? And then back to it, we just have our b over 2a squared. So, how do I get rid of this square term? Because I can't really do much with this square term over here just to solve for x. So you'd say, okay, fine, let's basically get rid of the square term. Maybe you can just take the square root of both sides. Then what do I get? I get b over 2a is equal to the square root of b squared minus 4ac. Okay, this like totally makes sense, because all I did was I just switched around because I just didn't like the weird minus sign just sticking out over there. So I just kind of just basically just moved this b squared over there. That's all I did. Over 4a squared. Now also we know that the square root is either the plus or the minus square root. Just to be safe. Now how do I solve this? This seems like a very intriguing problem. How do I do it? Well, I just see this now I just have this kind of weird term just sticking out. Maybe I can bring it over. But then before that, I think it would help to simplify this expression over here. My b squared minus 4ac over 4a squared. Maybe you can simplify it. And the way you simplify it is, if I were to ask you the square root of 25 over 64, what would that be? Well, I mean, what would you say? I know, it's like a very random question. You'd say 5 over 8, right? Simple, just say 5 over 8. And then if I ask you how you got it, you'd say, okay, well, I just took the square root of 25 and 64 and just put them in a fraction. So without you actually knowing it, what you're doing, without you actually knowing it, you're just kind of using the property of square roots that says that the square root of a fraction is a fraction of the square roots. So what does it mean? Well, that means that I can simplify this expression. So this would be equal to, I just said, so we see a fraction over here. So this would be b squared minus 4ac over, this is again the positive or negative square root. What is the square root of 4a squared? Well, it's just 2a, right? Over 2a. Now we can bring the b over 2a to the other side. So it'll be x is equal to negative b over 2a, right? Plus, right? Plus, because there's a plus in front of it. Well, it's actually plus or minus. Sorry. I got a little bit confused there. It's either plus or minus the square root of b squared minus 4ac over 2a. So now we see that we have the same like denominator. So we can simplify this, right? We can simplify it to x is equal to negative b, right? Plus or minus the square root of b squared minus 4ac over 2a. And this is called a quadratic equation. Whatever I've written over here, let me write it neatly. Negative b times plus or minus the square root of b squared. I'm just kind of color coding it to make more sense. Minus 4ac over 2a. And this is what the quadratic equation is. This is how you solve. So we basically kind of just generalized solving a quadratic. So yeah, that's nice. And we can actually test it out for any quadratic equation available. Let's say that my quadratic equation is 2x squared plus, I'm just putting numbers there, but 5x plus 3. Let's even actually solve this. You know what? No need. Let's not get too complicated over here. Okay, fine. Let me just keep it there. So what would this be? Well, again, what is a, b, and c? Well, a is the first term. So a is equal to 2, b is equal to 5, and c is equal to 3. So we just put it in there. Negative b, so negative 5 times, or plus or minus the square root of 5 squared, which is 25, minus 4ac, so 4 times 2 times 3. 4 times 2 times 3 is just 4 times 6, which is 24, over 2 times a, which is 2, so that's 4 over here. Right, so just get negative 5 plus or minus the square root of 1. And we know that the square root of 1, which is over 4, we know that the square root of 1 is just 1, because 1 multiplied by 1 is 1. So we get negative 5 plus 1. I'm just going to leave it as plus. It doesn't really matter. It could be a positive or minus. You're positive or minus 1 over 4. And again, this could be, again, kind of split up to negative 5 over 4, right? And then we can either add it or subtract it from 1 over 4. And boom, we are done. So we actually got the roots, sorry. So we actually got the roots to this equation right over here. And we can actually see, and probably this equals 0, but we can actually kind of see that if this actually holds true somehow. Let's even actually do it. So it will be 2 times negative 5 over 4. This will be a little bit more mathy in a sense. But anyways, you see, you just saw it. But we can actually kind of, using this quadratic equation, we've done it very easily. Otherwise, you'd kind of have to bring the 3, negative 3, and then divide by 2, and then do whatever we did over here. You see, it took a lot of steps to kind of get over here. All we did was whatever we do if we didn't have the quadratic equation, but then all we did over here was just with a bunch of variables, and that's literally it. So hopefully you liked my video. Please, if you have any improvements on it, please tell me in the comments. Thank you. Bye-bye.